Hey everyone, welcome back to my channel. If your Databricks queries are running slow and your data become huge and you have no idea why things are getting slow, no worries. We will fix all these things in this video. Welcome to the day 10 of Databricks series. And today we are going to talk about something every data professional needs to understand. That is performance optimization. So without wasting any time, let's get into it. So today we will cover four things in this video. The first one is how to read query execution plan. And the second one is partition strategy to organize your data in a smartly way. And the third one is the game changer for the query execution plan, that is optimize and zorder. We can use optimize and zorder to organize our data. And finally, the fourth one is that is cachening techniques to make repeat queries lightning fast. I will walk you through each one concept with the real world example so that you can also understand in a better way. Okay, so imagine this. You walk into a city, you have no maps and no GPS, but still you start walking and hoping you will reach your destination. That exactly Databricks does without having a query execution plan. A query execution plan is a map for your query. It tells you a step by step how Databricks can actually run your query and what it scans and where it's spending time and what is the bottleneck. Let me show you this in a practical way in Databricks SQL editor. So as you can see here, so I am in the SQL editor. So I'm just going to run this query. You can see here. So I have the customer churn data. I'm just going to check the count of the all churn customer data. So I have simply write the select star from workspace and the table name that I have selected, and I have used where condition where customer status is equal to churn. I simply run this query and let's see how much time it. And now as you can see here, the output, this is your query execution plan, the step-by-step process how the Databricks actually run your query. So as you can see here, so you will see here the filter option. As you can see, if you can first, what it can do, first it will check the filter, then it will fetch the data from the table. So it will search all the table, like how many, the number of rows that we are having in the table. So all the tables, all the rows data, it will scan one by one if you will use star. So this was like 10,000 rows. Imagine this in a big company, in a company like Amazon, Flipkart. There are 500 millions of orders, billions of orders of data is there. If you'll use this same query there, select star from the data and where customer churn is going to churn, then it will take a huge amount of time, like 15 to 20 minutes or more than that also. So this is more expensive or more time consuming for the companies. That's why we can get to know the query execution plan. So where it is scanning and where it exactly taking time. If it will takes more than 20 minutes, 30 minutes or 40 minutes, then cloud will take more expensive, more charges. So it is too expensive for the company. So that's why before doing any partitioning and all everything, we should run the query execution plan. What exactly the query execution plan? So if I will tell you the real world example, imagine this in Amazon. Imagine this in Amazon or Flipkart. There are 500 millions of data of orders are there. If every time if we scan all the data in that table, so whenever we load the dashboard will take 10 to 15 minutes or more than that. So companies can't bear that much of time and money. So that's why before running a query, you should explain that query and read the plan. All right, now let's just talk about the partitioning. Here is the simplest way to understand this. So imagine you have a huge library, like more than 10,000 of books are have in your library. All are mixed together, no order, no section. And someone came to your library and asked, give me all books which the year is 2020. Then what you could do? You will just go and search all the 10,000 books and give the 2020, but it becomes very slow and it will take more time. But what if your library was organized? When the customer will ask, give me the 2020 books, you will just go to the year of that 2020 year which is you have organized. You can just go the 2020 yourself and you can pick up all the books and given to your customer. This is how simple. So that's why we can use partitioning for to organize your data in a order way, so that whenever you can want to fetch anything, like whenever your customer will ask anything like 2020 years book, then you can give that books without reading all the 10,000. This is exactly what partition does to your data. Let me show you in the Databricks practically, so you will get better understand. So now, as you can see here, so I have the Airbnb 2019 data set. So I have just write the simple SQL query is select star from the table. So this is the data that we are having. So what we are going to do, we are going to partition the two columns, which are, one is the neighborhood group and another one is the type of the room type. How we actually partition those two columns, let's just see. So before we apply the partitioning on both the columns, for that what before that what we have to do, this is the table reference. So in the Databricks Spark can't read the table reference. For that, we have to convert the table into the data frame. What we can write, so we will store that our table into the df variable, like to write the spark dot table and write the table name. In the df variable, I have stored this Airbnb 2019 table. Now we are going to partition both the two columns, which are neighborhood group and another one is room type. So because those two we most oftenly use in the where condition, and you can partition so many columns, but make sure you should partition those columns which are having less unique values. You can't apply the partition in customer ID, mobile numbers, email address, which are having more unique values. If the column has more unique values, if you will apply partition on those columns, then those columns create small multiple files, which becomes so much huge file, so that your data query runs slow. That's why you should apply the partition which the columns have the unique values less than 10. So those columns only you should apply, and that too also you should apply the columns which are you most oftenly use in the where condition. So here how we can apply on those columns. So for partitioning of those queries like neighborhood group and room type, you can write this query. You can see here the data frame like df.write and partition by these two columns in the format of delta and save the table as in the partition Airbnb 2009. So this is how we can apply the partitioning in the columns which we want to add. So whenever you write a query, like I will show you the example. Let's write a SQL query. So whenever you write this query, select star from the partition event 2009, where neighborhood group is Manhattan. Even though if you have the millions of the data, if you apply the partitioning on these columns, then it will not scan all the table. Even though if you will write the condition where neighborhood group is called Manhattan, then it will not scan all the table. It will just directly go to the neighborhood group which is Manhattan category. Then it will fetch the data. That's why we can use partitioning to become our query faster. So now let's just look at the optimization and the order, what it is and why we can use that. Imagine this is the most powerful for the delta lake, especially when you write the queries in your delta table, especially in streaming and frequent updates, and the delta table end up with the small sized files. Small files are the nightmare for the performance. Each file you should open, read and close. More files and moreover, that's where optimize will solve all these issues. So now we are going to optimize our Airbnb 2019 data. I use the optimize keyword to optimize my Airbnb data. So as you can see, I use in the spark.sql and optimize Airbnb 2000, and you can see here this code is successfully run. So this one command takes all those small files into a large and efficient files. So think of it like you have 1000 sticky notes all have with the data. So what we can do, we can use this optimization on those 1000 sticky notes, and those sticky notes will convert it into 10 neat notebooks. So it is faster and easy to read. So that's why we can use optimization to organize our data so that we can fetch the data faster and quick read. Now let's just discuss about ZORDER. Let me just give you the real world example. Picture this, you have entered into the DMart store. All the milk products is in one side of the corner, all the fashion product is one side, all the grocery part is in another side, right? So that is called a z order. Even though if in our data, if we will use z order, so let's just do the practical way. I have write this, so what it can do, so what this z order will do, this z order will do, all the Manhattan group of the data will keep a one side, all the another kind of neighborhood group will keep another side inside that data, so that whenever we'll fetch the data, it is easy to if we want only Manhattan data, then before using z order, it must be take 4 minutes or 5 minutes for to fetch that only Manhattan data. Then after using this z order in that data, whenever we will fetch the Manhattan neighborhood group data, then it will take only 30 seconds. So that's the power of z order. So that's all about optimization and z order. So in short, if I will say, if you'll go to the DMart supermarket, there all the data will be organized, all the data will be in the shelves neatly, so that is called optimization. And all the milk product will be one side, all the fashion product will be another side, all the grocery part will be another side, so that is called the z order. So that's all about optimization and z order in the Databricks to optimize our query faster to get the results. Now we are going to learn about what exactly the catchy techniques. It is simple but give you the powerful results. When you run a query, the Databricks the Databricks has read the data from the storage, which takes time. But if you keep running the same queries multiple times, then it's taking too much of time. That's why we can catch those queries or those tables, and we can keep it in our memory and read from the memory, which is 10x faster to fetch the data. Let me just show you the how we actually do that. For catching the data frames, you would use this code, as you can see here. So like I am using in the Spark, so df.catchy and df.con. With this we can catchy our data and we can store our data into the memory, and whenever we will fetch that data frame, Airbnb data frame, then it will, instead of taking 30 minutes or 20 minutes, it will just take 1 minute or 30 seconds. So that's why we can use catchy to reduce our time to fetch the data. So the catchy will help us to, whenever we will fetch the data, it will not read data from directly from the storage, which takes so much of time. If we will keep doing the multiple times on the same queries or same data frame we are going to fetching, so instead of that, what we can do, we can catch it and store it in memory and read from the memory, so that it will take less time to actually we can read the data from the storage. As you can see here, this serverless compute is not supporting this cache technique, but whenever you will have the premium one, then it will be definitely support, like cache table and the table name, so that this table will store in your memory. But here it is not supporting cache technique because I am having the serverless compute, I don't have the like premium version, so that's why. So that's all about this video. Let me just quickly recap what we have learned today in this video. So we have learned about query execution plan to explain by using explain we can get to know how our query will be executed. And the second one is we have learned about partitioning to organize our data in the cells in a organized way. And the third one is we have learned about optimization and z order techniques, why we use that. Like optimization is organize the data, and z order we can use to group of the same similar data. And the fourth one is catchy techniques we can use whenever we will run same query multiple times from the one data, so we can catch it and store in our memory. So I hope you learned something out of this video. That's all about the Databricks that we have discussed. Thank you for watching this video.